right, welcome to the second technical session of the day. Technical session number 36. Implementing hard drives in Windows for the most part. We are going to, throughout this technical session, be able to explain the purpose and methods of hard drive partitioning, explain the purpose and methods of hard drive formatting, and identify common hard drive problems and explain how to maintain and troubleshoot these issues. Throughout this technical session, we want to keep in mind a couple behavior skills and mindsets, like teamwork. IT is a team sport. We do not know as much individually as we do collectively. Utilize the strengths of your team and you will be much better problem solvers along the way. Also, persistence. We need to be persistent in things that we don't fully understand. We may not know it now, but we will know it in the future. We want to pursue this knowledge. If we want to be successful in IT, we need to be interested in IT. Persist in finding answers to common problems and then more and more complex problems as you move along. If you hand something off to third tier, follow up, see what they did to fix it, add that tool to your toolbox so you can become a more valuable member of your team. All right, partitioning. What does that mean? It is essentially the process of subdividing a hard drive into smaller and smaller units. We're doing this electronically, not physically. And we call those partitions. There must be at least one partition. But partitions will allow us to do all sorts of nice things, like run multiple operating systems on the same hard drive, one per partition. And Windows supports three main partitioning methods. You have the MBR, or master boot record. You have the Windows proprietary dynamic partitioning scheme, also known as dynamic disk. This is one of the more common ones. And then you have GUID partitioning table as well. All right. So I've been talking a lot lately. Why don't we get Luis? Can you read for us, please, sir?
Alrighty then. Hard drives using MBR partitioning scheme have a tiny bit of data in its first sector that is also called master boot record. MBR also contains the partition table, which describes the number and size of partitions on the disk. MBR partition tables support up to 4 partitions. When the PC boots up, BIOS looks at the first sector of the hard drive for instructions in the partition table to determine which partition contains the active operating system.
Very good, thank you. So the MBR is kind of your map for your partitions on your hard drive, allowing you to set up multiple operating systems or just the main operating system, and kind of tells it where do you go to find those pieces that you need to be able to construct the operating system upon startup. Questions?
So if I wanted to destroy your hard drive, I could just wave the magic MBR destroying one, and bam. That's all I need. If you get rid of the map, it's like trying to find a treasure. If you get rid of the map, you can't do anything. So it's not a question, but it is kind of a question. You should know that the MBR is the map of the hard drive, and without it, you're up a creek. Metaphorically, not logically. Unless you're up a creek.
All right, on this one, Jamie, read for us, please.
NBR partition tables support two types of partitions, primary and extended. Primary partitions support bootable OS, while extended partitions are not bootable. A single NBR disk may have up to 4 primary partitions, or up to 3 primary partitions and 1 extended partition. Primary partitions are usually assigned drive letter, starting in C. Each primary partition on a single drive has a special setting stored in a partition table called active that determines the active partition. Grub Boot Manager is used to control multi-boot setups with one Linux OS.
Yeah, so within the Linux ecosystem, you would use Grub for determining this. Thankfully, Windows makes it pretty easy. They have a GUI setup in the dynamic disk where you can go in and kind of manipulate your partition tables, set up extra volumes, all kinds of fun stuff. You can do that on your computer, and it's a good thing to practice. Also, there are virtual machines that will allow you to do it in both Test Out and Coursera. You get to do both. Yes, Avery?
But there's a good test out lab for it
Oh,
that
man,
we should do.
We keep hearing about this. Test Out. Okay. There's a good lab. I see like eye rolling in the background, just like, oh, more Test Out labs.
They're worth it.
Take it for somebody who got success out of it. This is true. All right. Now, extended partitions can contain multiple logical drives, each of which can get a drive letter. So a logical drive works kind of like a primary partition, but you can boot an operating system from it. So you can have additional drives attached, and you can operate or add them to the tables and even boot from them if you so choose. Questions? All right, mostly just definitional at this point. Dynamic disks. Let's go to the sticks here. Oh, nope. Umberto.
Dynamic storage partitioning or dynamic disks create structures called volumes. The number of volumes that can be created in a hard drive is not restricted. Dynamic links allows to implement RAID, span, stripe, or mirror over multiple drives. Only the lower end version of Windows 7 don't support dynamic disk.
All right, so who wants to tell me what the difference is between spanning, striping, and mirroring? What are the difference between those three things? All of them require multiple drives. So we're talking about, you know, there's a term here we should be pretty familiar with right here. Anybody want to be bold enough to step up on that one? I mean, I could drone on here all day. I've proved that repeatedly, but I would like to hear from you.
Calling someone Kelly.
All right.
You know what
Going to the
Diego would
sticks.
say right here, right, Kelly?
You what?
You know what Diego would say right here, right? He said it today to me. Be like,
What's
Marvin,
that?
got a whole bunch of experts in here already. They just know everything.
They don't ask
Like,
questions.
nobody's talking to me. They just know everything. They don't have any questions. I'm like, no, Diego, they're just taking it all in, sir. Give them a second. So I'm giving y'all a second before y'all answer. Take
All right.
about
So our analog randomizer has chosen Janina to explain the difference between a span, a stripe, and a mirror. The floor is yours, ma'am. I think your microphone is muted. Oh,
How convenient.
saved by a technical issue.
Hello, can you hear me now?
I can hear you
Yeah.
now. I can hear you now.
Okay. I remember two, if I'm not mistaken. Spanning is the spread of the storage between all the disks, and I
Okay.
think mirroring is when you copy the same thing from one disk to another.
Okay.
Meaning they're the same, and I forget what stripe means.
All right. Go to phone a friend.
Call someone who doesn't look like they're paying attention, Janina.
All of a sudden, everybody's like,
Trying to set me up.
I can go back to the analog sticks. here. Oh. Oh. They're not here. Chris. Spanning, striping, mirroring. What is the difference, please? Oh, we got mirroring. What's
Yep.
the difference between spanning and striping? Three, two. TJ. What is the difference between spanning and striping, please?
I know about striping, but the spanning one is throwing me off.
Okay, well, what's striping?
When you stripe data across two multiple drives, back and forth.
It's getting there. It's getting there, but we're using the name in the definition. We can't use the name in the definition. We're getting there. So striping in and of itself breaks up the data. So if you have 3 drives, it's writing bits to each of those drives. So it'll be like bit 1 goes to drive A, bit 2 goes to drive B, bit 3 goes to drive C, and then it starts all over again and breaks it down across all 3 drives. That's striping. So you're striping the data across all 3 drives. Spanning allows you to logically view multiple drives as a single drive. So, I mean, you could write everything to one drive, but it's viewing like if I add like, 3 1 terabyte drives to my computer and then span across it, it views it as if I have 1 3 terabyte hard drive. But I can still, when I save it, it's likely going to fill up 1 first, then the next, and then the third. Subsequently, like water falling over. It's not striping the data across all 3 drives intentionally. Does that make sense? So if one of the drives in a span fails, I only lose what's on that drive. I don't lose everything. Okay, so striping, if I lose 1 drive and I have 3 drives, then I lose everything. Unless it's a RAID what? Seen some people mouth it.
Say it, Mark.
I was gonna say 5.
Yes, that's correct.
Yeah,
Janina.
RAID 5.
RAID 5, which is striping with
Parity.
Parity.
parity. Very good. Very
Good
good.
job, guys.
Gives you that little extra security in your disk management. So in dynamic disks, this is where you can set up and run a software RAID on your systems. All right. Good. Alan here. Runs back into frame.
Ellen might be away at the moment.
I just got back.
Okay, okay.
You want me to explain what good is?
I was just gonna say, read the slide.
Oh,
Go ahead, explain it.
Yeah,
I'm about to.
we're listening.
The global unique identifier partition table GPT scheme is very similar to MBR, but improves MBR scheme's limitations. Limited number of partitions, Windows limited to 128, partitions larger than MBR, limit to 2.2 terabytes. GPT is arranged by LBA instead of sectors. LBA is 0, and it is a protective MBR, a recreation of the master boot record from the MBR devices. So disk utilizes known as a GPT drive disk, and don't mistakenly overwrite any partition data. Sorry, I'm stuttering. GPT drives uses a GPT header and a partition entry array. Both are located at the beginning and the end of the drive, so there is a protected backup copy. The partitions on a GPT drive go between the primary and backup headers and arrays.
Thank you. So essentially, it is an expanded version of that map, where before with the MBR, we were only allowed 4 partitions. Now we can move up to 128 with Windows, even more with Linux. With an MBR, we had a maximum partition level of 2.2 terabytes. Now we can go much beyond that, which is a good thing because operating systems and hard drives are getting very large at this point. Like I was saying, I have a 16 terabyte hard drive attached to my computer right now. And probably in about a year or so, I'm going to have to upgrade that because file sizes are getting larger. Media is getting more data intensive. Now, see here, Mark, can you read for us on this one, please?
GPT conditions. Windows. Windows can only boot from GPT on a UEFI-based computers running 64-bit versions of Windows 10, 8.1, 8, 7, Vista, and corresponding server versions. All versions of Windows 10, 8.1, 8, and 7 can read GPT drives and use them for data. They just can't boot from them without a UEFI motherboard. Other operation systems. Other operation systems can also use GPT. Linux has a built-in support for GPT, even with older BioR or UEFI firmware. Apple's Intel Macs no longer use Apple's APT, Apple Partition Table scheme, and use GPT instead.
Thank you. So it has to have a UEFI based computer. What did we use before UEFI?
BIOS.
BIOS. How do we tell the difference?
UEFI has a graphics user interface, and the BIOS doesn't. It looks old. You use your keys in order to go to the different options.
Very good.
And yeah, that's pretty much it. I'm not gonna overtalk a lot, so
That's my job. But with UEFI, you can use the mouse, all that kind of fun stuff. So it's pretty easy to tell the difference when you boot into it, which one you're using. So GPT is going to require that you have the upgraded UEFI system, though most systems coming out now do. All right. when to partition. Let's see here, Romario.
He stepped away. I don't know if he's back yet.
Okay. All right. Rienzi. You are muted, ma'am.
Oh, sorry.
No worries. I do it all the time.
When to partition. The two common situations that require partitioning are: one, when installing the operating system on a new system, or two, when adding a new drive to an existing system. When installing a new OS, the installation program asks how to partition the drive. When adding a new hard drive to an existing system, every OS has a built-in tool to help partition it. Windows offers different tools for partitioning hard drives. CLI program called FDisk is the oldest one. Modern versions use disk management located under computer management and administrative tools.
Thank you. All right, what's CLI? It's a CLI program. So what is CLI?
Command line interface.
Command line interface. It's this screen right here, otherwise known as the terminal, shell. It allows you to interact with the computer on a command line basis rather than a GUI overlay, which would be what you would see over here on the right side. We will have a technical session where we will get pretty heavily into command line interface, various commands you will use and stuff like that. So if you are not overly comfortable with that just yet, we'll get there. All right. Next, hard drive formatting overview. What does formatting do? A lot of people think it erases the entire disk, just makes it so that it is just clean and fresh, like it was never written on before. Well, maybe if you do a very low level format, that's the case. Typically, that's not what's happening. What's happening when you format a drive is it's creating essentially a file system on it and basically telling the system it's okay to write over what is already here. So if you were thinking that formatting erases the drives, no, everything is still recoverable on that drive, even if it has been formatted. Now, second thing it does is it makes the root directory in that file system. Root directory is kind of the foundation in which the operating system builds files and folders and all that kind of fun stuff. When we say if a virus or something is given root level access, this is why it's so devastating, because you can really do a lot of damage if you're able to mess with core operating system files. You could tell the system to go look in another location when it's booting rather than operate from the files that are already in place, thereby allowing either you administrative access or infecting the entire systems or what have you. And each partition within the system must have a format in order to hold data. And also so your system knows how to interact with those various types of formats. Now, disk management is the built-in formatting utility within Windows for everything from Vista up. Now, current versions of file formatting that is utilized by Microsoft currently are FAT16, FAT32, FAT64, also known as exFAT, and NTFS. What are those, you ask? Don't worry. We're going to get into it. All right. FAT16 breaks everything down into a little bit like sectors, essentially. Each sector stores up to 512 bytes per sector. If you're writing a file to that particular drive, if you have a file that is, say, just for the sake of argument, 550 bytes, when it writes that 550 byte file is going to take up 2 sectors, and the remainder of that other sector goes unused. It basically writes base code in there, essentially like filler, to fill up the rest of that sector itself, and it goes to waste for the most part. All right. Now, FAT stands for File Allocation Table. It was the initial data structure used for indexing the files where they're located. It helps you keep track of what files go with each other, lets you know when you've come to the end of a file. It utilizes a hexadecimal marker from 0000 to FFFF. And there are 64,000 sectors that can be tracked for the most part. The right column on a FAT table contains the information on the status of the sectors that are stored. And then the formatting marks the good sectors with code 0000 and a bad sector with FFF7. Lets you know that you cannot write to that sector. Here, well, I think on the next page, it'll give us an example of what it looks like so we can kind of break it down. Now, so FAT16, 64,000 files at 512 bytes per sector gives you a 32 megabyte cluster, essentially. So, clustering refers to a combination or combining a set of contiguous sectors, ones that need to go with each other in order, and treating them as a single unit in the FAT. These units are called clusters, and the size of the cluster is not fixed. So the larger the partition, the more sectors per cluster, and the new FAT16 can support partitions up to 2 gigabytes. Not very large, is it? That's the most recent update. So the maximum size of a partition under a FAT16, 2 gigabytes. Where might we see this be used currently? Can we use it for hard drive on our phone? 2 gigabytes be pretty good for that?
Hold on, so it can go up to 2 gigabytes, right?
That's it.
So I'm thinking about that some flash drives that are around that amount of memory, we can use FAT16 with that, honestly.
And that is a good assumption. That's exactly what it is predominantly used for at this point. It's used on jump drives or flash drives, smaller than 2 gigabytes. It's becoming, memory on flash drives is becoming cheaper and cheaper. So you're starting to see really inexpensive 32 gig, 64 gig flash drives and stuff like that. So you're not really seeing many of the 2 gigabyte drives much anymore. I mean, why would you spend $1 on 2 gigs when you can spend $2 and get 64? So not as common anymore, but 5 years ago when this was written, absolutely very common. All right, so here is an example of a file allocation table, what it would look like. Get my annotator out here. So you can see this would be the name of the cluster. So you have that 3ABB. Tells us that it is good to go, right? And then 3ABC right next to it, good to go. 3ABD, what does this mean? What does it FFF7 mean?
It's a bad sector.
Bad sector means we cannot write to this sector on it. So this is what it would look like once we've started. So you have when you've initially formatted, any sector that's good to go, ready to write to, has a status of 00000. Once you start writing to the drives, the status, after you have your cluster, the status will tell you where to look for the next sector in that cluster. So if you have 3ABB, the next one will tell you 3ABC. So you go down to 3ABC. There it is. That's the start of that cluster. And then once you're done with it, it tells you to go to 3ABE. Why? Because D is a bad sector. We can't write to it, so we had to skip over it. And then we have 3ABE. But the map is directing us there. So that 3ABE skips down to 3ABE here. And then at the end of the cluster, when we are done, there's no more information in that system. We go with FFFF. That lets us know that it is finished. You can see it in the very next one. We have 3ABF. You go to that, and then it says 3AC0. Jumps down to the next one. That's where 3AC0 is. Goes to 3ACI. Tells us that's where that next file is. 3ACI, done. FFFF. That is the end of that cluster or file. Now, as you can see, if you're not moving stuff around, if I'm start deleting files and adding files, and all of a sudden we have to start jumping around like it shows right here, where it goes, 3ABC, 3ABE. So I have to jump over this bad sector. I have 3ABE. And then as there was a file there initially, I now have to jump down to 3AC4. So skip over this cluster to go to 3AC4. Then I got 3AC5 down here, and then 3AC6. And then my file is ended because originally there was a file here when I was writing. And so in order to finish out writing that cluster, it had to jump over that file. So this is where defragmenting comes into play. So initially we had to jump around to find these files, which slows our computer down. So when we defragment it, we rewrite these things to the drive. And instead of having to skip over this section, we put all of it together so that it's quickly and easily readable. Does that make sense? Yes, no, thumbs up, thumbs down. All right.
What do these letters? What do these letters signify again?
The cluster itself on the drive. It is 3 hexadecimal notations. And then if you go to the beginning, like when you first format it, if it's a good sector ready to be written to, it'll come out as 0000. If it's a bad sector, it will be FFF7. And remember, we could have up to 65,000 different clusters, right? In FAT16. You don't need to know how to do this. This is just kind of giving you an idea as to how the memory is stored within the system. So, yes, Rienzi.
When you say that FFF7 is bad, mean that it's already written to or occupied?
No.
No, it's bad as in it's corrupt.
It's a damaged sector, meaning we can't write to it. Okay. So if you see over here, this is what it looks like right after we're done formatting it. So there should be nothing on this drive, and you go down and then you have this one bad sector here and everything else is good to be written to. And then when you come over here, where it says a cluster, that's the start of that cluster. And then where it says status, that tells us where to go to look for the next section. And it will continue to do that until you get to the end of the file, which will show FFFF for the end of that file itself. Kind of makes sense. It's just meant to show you logically what they're doing with the drives. Main takeaway would be how to identify a bad cluster, FFF7. To load a cluster is good to write to 0000. And the ending of FFFFF to mark the end of a file. That's your main takeaways here. All right. Next, FAT32 uses 32 bits in each cluster, support partitions up to 2 whole terabytes, which is pretty good. Allows for a much more efficient use of disk space, and it's able to make multiple smaller partitions as needed. However, it still requires regular defragmentation. It is pretty commonly used today still, especially in like jump drives and things like that, but not for the operating system partitions themselves, because they would typically use the NTFS file system. But smaller than 32 gigabyte hard drives is typically where you see it.
This is for like hard drives, actual hard drives. Can a FAT32 be considered, can have SSDs as well, or just like simple hard drives? Like,
yeah, I mean, you can see it like down there, it says USB drive, so it can use it for smaller USB drives that are typically used in drives smaller than 32 gigabytes. When you get above that, there's typically another file system you would use. But yes, absolutely can use it on SSDs, just smaller drives. All right, any other questions? All right. NTFS, or New Technology File System. Uses a much more complex and powerful file allocation table than FAT16 or FAT32. It offers a lot of improvements upon these other systems, where it actually allows for redundancy, security, compression, encryption, that's a big one, disk quotas, and cluster sizing. So we can adjust the size of the clusters we wish to utilize. And it is currently the most common file system being utilized for operating systems because of these added features. It does not, or it is not utilized on external drives and flash drives because of the security and encryption can make access extremely difficult when moving data between systems. Now, instead of using the FAT system, it uses something called the master filled table. And the partitions keep a copy of the MFT in the middle of the disk to reduce the chances that the MFT would get lost. Now, NTFS views individual files and folders as objects. Remember that it views individual files and folders as objects and provides security for those objects through the ACL. Where have we heard the ACL be used before? Or
In
access
firewalls.
firewalls, access control lists. So it's much more identifiable through the access control list to help control the movement of those files as necessary. All right. Now, let's expand into some of these features just a little bit more. Compression enables you to compress individual files and folders to save space on a hard drive itself. However, the downfall of that is when you compress a file, your access time to get to that data is much slower because it would have to decompress and compress it every time you open it and every time you save it. So you're sacrificing some processor speed, but saving on space. Now, NTFS uses the encryption file system, or EFS, which allows you to encrypt an individual file, a folder, or a folder full of files. Now, if we wanted to encrypt the entire drive, what would we use?
Repeat.
If you wanted to encrypt an entire drive, rather than just individual files, if we wanted to encrypt the entire drive, what would we use?
BitLocker.
BitLocker. Very good. So BitLocker encrypts the entire drive. EFS encrypts individual files or folders. Encryption, absolutely a wonderful thing, but also understand the processing power that is in play when you're dealing with it. So the more robust your encryption systems are, the more processing is needed in order to encrypt and decrypt things, especially in active use. So there is a trade-off when dealing with them. Avery, you look like you want to say something, man.
I'll tell you about it later.
Okay. It's good to hear. All right, disk quotas. It allows you essentially to set how much of each drive you can utilize, or users can utilize. So you could say, like, you can't use more than 50% of the drive, and allowing you to save on space, or encourage users to utilize shared drives for saving their files too. All right. Next, cluster sizes. It allows you to adjust the cluster size, which is nice. You don't have to go with what is automatically set, but by default, it supports partitions up to 16 terabytes on a dynamic disk, though only up to 2 terabytes on a basic disk. Questions so far? All right. FAT64. Fidel, you read first, please.
Since FAT32 only supports drives up to 2 terabytes and files up to 4 gigabytes, a new file system was created, exFAT or FAT64. It supports files up to 16 exabytes and a theoretical partition limit of 64 zettabytes. The file table extends to 64-bit cluster entries. The exFAT file system is used by large capacity removable storage devices such as large capacity USB flash drives, memory cards, and some external hard drives. USB drives don't use NTFS because its security and encryption make access difficult when moving the drive between systems.
Very good. Thank you. So NTFS used on your internal drives, typically the one utilizing your operating system, external drives, things like that, you would typically use FAT64 once you've exceeded 32 gigabytes. Why do they say a theoretical limit of 64 zettabytes? Does anybody know how big a zettabyte is? I think if I'm not mistaking the terminology, if we took all the information saved on the internet currently, like everything currently saved, we would hit just over 1 zettabyte. I could be mistaking my terminology, but I think that's about how big a zettabyte is. Am I correct in that, Avery, or no?
That sounds right.
I'll back you. That sounds pretty close to being accurate, if not
Yeah.
100%. I always leave myself out.
Yeah, I could be wrong in that, but I think that currently, if we took everything, all known downloaded digital material, we would just barely exceed a single zettabyte. Wait 10 years, we'll probably have zettabyte hard drives in our house. What'd you do this weekend? I downloaded the internet. All of it.
Kelly's about halfway through.
Nice.
There's a commercial back in the late 90s, early 2000s. Shows guys like they're talking about how fast the internet speed was. And the guy's like sitting there clicking through all these videos and just, looking at all this stuff. And it said, congratulations, you have reached the end of the internet. So that one's kind of funny, especially nowadays. All right. Other formatting options that can be utilized on Linux, since they like to do things differently, we have ext4, which is the default one in most Linux distros currently. So ext4. Older ones may use ext2 or 3, but if you see the ext and a number, understand that that is a Linux system. Yes, you may get a question on that, though it would probably be only like one. So,
But get that one question right.
yeah, it's a gimme.
We're
So
telling
we gotta
it
get,
to you
we gotta
here.
get that one question. It's a gimme. Just gotta remember.
And Kelly, your estimate was correct in 2016 per zettabyte.
So yeah, Linux file system is able to utilize the NTFS, FAT32, FAT64.
Excuse me, I was serious.
I know. Or the HTF Plus from Mac, as well as utilizing their homegrown systems. ext4 not compatible with Windows, while ext3 still is. It supports volumes up to 1 exabyte, individual file sizes up to 16 terabytes, and can directly in the directory can contain up to 64,000 subdirectories. That's a lot. And it also is able to improve your performance and reliability from ext3, which is always a hope when you move up to the next version. Questions so far on this one? Bunch of experts, apparently. We're good. All right. Now, other ones you may come across. This is another one of those ones, kind of like Windows Updater. Okay, my wife wants me to tell you that she says she's an awesome teacher.
I am.
This is directly from her mouth. Obviously, a very humble person.
We know, Allison, we know.
I am awesome math coach.
There you go. See?
Yeah.
Right from her own mouth right there. Now, like Windows Updater, it seems like it's a little too on the nose. You're like, oh, that's too easy. There's no way that's the name of the answer. That's the answer to this question. The same for CDFS or CD file system.
Yep.
So it is a formatting system for CD media.
Nice.
All right, hold on one second.
I think it may come up, but if it does come up, they're asking for the file media for CD is CDFS. It's
Yeah, that is a
right in your
question
face.
that may or may not come up. I think I've heard of people getting it, but yeah, just it is that easy. CDFS, CD file system. So
Can't remember if I got it or not. But if I did get it, I got the question right.
Well, you opened up we got on a tangent. So how many what's the storage capacity of a CD? Let me see. Kelly, you can stay off mute. Storage capacity of a CD, Luis.
I'm gonna pass it around to somebody else because I don't remember that
Oh
one.
man. Luis didn't burn CDs. Okay. Who looks like a CD burner? Evan used to burn CDs.
Yeah, no, I didn't do that. I'm kind of young.
Oh wow. Burn.
Oh,
I would say that was hurtful.
burn.
Evan, I'm muting you, man. Burn. I see what you did there.
Making
Janina.
enemies today.
I know, man. Hey, it's all good. Janina, what's the file capacity? What's the size of a blank CD? Jimmy, I'm coming to you next. You better be looking it up. Okay, you good? Okay.
He Googled real quick.
Yeah.
I don't recall. I don't recall if it was 800 or 900. I don't recall.
Well, it's neither, but you're close. Go down one more. What you got, Jimmy? It does look like he's doing a lot of screen looking. What's going on? Why you popping your head?
732.
It's 700?
700 megabytes.
Yes.
700 megabytes. Okay, that's CDs. You know what I'm going next? I'm going to the DVD next. Just regular DVD, because there's levels to DVD. So we went from 700 megabytes to Mark. Looking a little worried over there. Go ahead and bring it out.
I'm still racking my brain to figure that one out, but I'll take a guess from 700 megabytes to 2 gig.
Times 2 plus 7. 4.7 gigabytes on a DVD.
Okay.
Raise your hand if it just seems like such a long time ago we were talking about the length of the amount of storage you had on a CD or DVD ROM.
I know, man. It's throwback. Okay.
90s.
No, I'm saying in this course. How long ago was it we were talking about the storage capacity of a DVD ROM?
Yeah,
it feels long, but we haven't been long. We haven't been together that long, but it feels like it's been a long time since we talked about this. Renzi, Todd, you next. Blank Blu-ray. What's the size? Regular blank Blu-ray.
I don't know, maybe twice as much as the
twice? Yeah, it's a little bit more than that.
Yeah.
But you are going in the right direction, being that Blu-rays is better quality and whatnot. Todd, you have it for me?
Jimmy looks like he knows the answer. Oh.
Who looks like who know what? I don't. See that he helping you out, Todd.
25.
What did you use? Did you use Safari on the phone, or did you use like Chrome, Mozilla, Firefox? What search engine did you use, ma'am?
Chrome.
Okay, I like Chrome. Chrome works. 25 gigabytes. It will come up.
It's so trusting, Marvin.
It's not just numbers that we like for you to this. It will come up. So maybe even tomorrow in a Kahoot.
Can you give that numbers to us again then? So I can write it down? Thanks.
Nope.
Why not?
You got a graphic?
You have it?
There's a JPEG we gave you.
It sure is. It should be one I know for sure.
Yeah, we have one for that.
He's real good about handing out the JPEGs.
Look at Jimmy helping out in the chat. That's what I'm talking about. Be a team player, sir. All yours, sir. And that's just first level.
Yeah, we're not even getting into Double
Exactly.
layer, single side,
Yep.
double side, single layer, double side, double layer.
We will though.
You what?
We will.
We're gonna have
No,
to go
we
over it again.
did. We
We
did,
did do
but
that.
We
he,
did?
yeah, he,
Yeah, and drives.
Yeah, I don't remember that though.
yeah, and drives.
Using
Mark,
drives.
is it coming down really bad? All right. Well, if you drop off, we know why.
Now it's just starting to crank up. I wasn't sure if that was thunder or not because it said it wasn't going to rain until tomorrow. But it's
Yeah, I
it's
know.
storming
I think,
now.
yeah, you may be on the outer band, maybe, but still, it's moved pretty good from out of the Gulf. So it's you guys are kind of around the corner of as it dissipating, but hopefully, if you fall out, we know why.
Should have a lot of mustard left in it.
I'm on.
No, you're not on mute.
Good question though.
Oh man, hilarious! All yours, Kelly. I just wanted to give you a little.
I appreciate it.
Yeah.
I'm not sure why she said she was the greatest teacher in the world. She just came in saying that and then walked out. So I'm not quite sure what happened.
Let me tell you why.
Sometimes you just gotta flex.
That's right. Well, yeah, we do that here all the time.
That may be, and also I just hit Avery up privately and said, "Hey man, Kelly is really in a groove right now. He's really doing it." I bet Allison sensed that and wanted to let us know that there was a better teacher in the house. So that's what it was.
I will concede to that because it's very different teaching to a group of people that are here wanting to learn versus a bunch of kids who are like, I don't want to learn this stuff.
All facts.
You know, so I will take that all day. People who are here willingly.
That's it.
All right.
And Avery, people here willingly.
And Avery, yeah, there we go. Qualifier. He still isn't living up to the dress code. Maybe next cohort. We'll see.
I'm not there yet.
Yeah, you got to cut it off, man.
Avery, what was your grade level that you taught? What were you?
I taught 5th grade.
Oh.
You literally couldn't tell me anything in the 5th grade. I knew everything. So I can only imagine what Avery went through during that time. Like, you couldn't tell me a thing.
I have stories, but
I bet.
But we're recording right now, so we'll
there we go.
We'll move on.
Names and faces are changed to protect the guilty. All right. Now, we'll finish up this technical session, then war stories. All right. NFS, or Network File System. It is a distributed protocol done by our friends over at Oracle with Sun Microsystems. And it was typically utilized for network access and allow you to essentially get to them as easily as if they were stored on your local system, even if you were utilizing different operating systems, be it Mac, Unix, Linux, what have you. So more common on an enterprise setting, not so much on a Soho setting. All right. Next. Quick format versus full format. So with both of them, files are removed from the partition essentially. And the difference being that quick does not check for bad sectors. This is a time-consuming process. It does not erase the data even better. It's just checking your drives for bad sectors to make sure so you don't write to bad sectors and lose whatever data you put there. So that is the big difference between quick and full. If you're operating off of a brand new computer and you're just changing up the operating system on it, quick is probably a good option for you. No big deal. Older systems, especially if the drive is more than 3 or 4 years old, I highly recommend the full format. Take the extra time just to see what sectors are bad on the drives themselves. Here is a good visual of the disk management tool. I am fairly certain there is a wonderful lab and test out that will help you create a new volume.
You know there is.
I know there is. It's almost like they knew we would be talking about it. And where to do it. And when you create these new volumes, you can choose what file system you're going to use, be the FAT32, FAT16, NTFS, or what have you, even exFAT. Highly recommend you taking the time to do that lab. If you're not able to do it now due to time crunch, maybe definitely set it aside to be able to work on it later. Most of these labs are very helpful. All right. Avery, you want to take over some of the troubleshooting for me? Or you want me to keep going?
Yeah, no, I'll do it. I'll
do it.
step up to the plate.
All right.
Got a question out there.
Yeah, I just wanted to know before you go, Avery, what does MMC stand for? Don't laugh. I just couldn't figure out what it stood for in the text.
What does what stand for?
MMC, the disk management tool. The book it says disk management MMC. And I don't know.
It's, you're like cutting out on my end. Could you type it in chat for me?
Sure.
I'm trying to figure out where you're seeing MMC.
The textbook it says disk management MMC.
Microsoft Management Console.
There you go.
And I had to Google it because I didn't know that right off. So that's not, but yeah, Microsoft Management Console is a placeholder where you can add various Windows tools such as disk management, computer management, performance monitor, and things of such. Microsoft Management Console.
Thank you.
No worries.
Did Avery just legit cut out the moment I said, hey, will you take over?
Wow. Wow.
I'm totally
no
never
longer
forgetting
here.
this.
He's no longer here. Like he literally all the way gone.
It's a little too convenient to claim, you know, it happened. I'm just saying.
He's knocking. Let's see what happens here. This is
little too convenient, Avery. Just saying, man.
Look at him. Look at him. Look at him. Look at him. Hello? Can you guys hear me? Hello?
Can you hear me?
I told you. Told you.
I told you.
This trick in the book. This trick in the book, Avery. You got to come up with some new ways, man. We've seen this. We've seen this. We've done this.
All right. 1 second. Day 21.
All right, you're live.
All right, troubleshooting, implementation, partitioning. So partitioning errors generally falls into 2 categories: failing to partition and making the wrong size. So to fix a partition problem, you're going to open disk management and do the partition correctly. If the problem is in a secondary drive, if the problem is in the operating system partition, use CLI or Windows installation tools. So for formatting, failing to format a drive makes the drive unable to hold data, and accessing the drive in Windows results in a drive is not accessible error or invalid media type error. So corrupted files can create the invalid media error. So you got to make sure you format your drives. Otherwise you can't use them. Some physical problems you might have. So physical problems in hard drives manifest themselves in several ways. Read-write failures, a lot of noise, or drive seems to disappear. So some symptoms: if mechanical drives begin to make any of the following sounds, it is about to die. So continuous high-pitched squeal, a loud clicking noise, a short pause, and then another series of clicks, and continuous grinding or rumbling. If that happens, the first thing you want to do is back up that data immediately.
I will tell you, once you hear that high pitched squeal one time, you will never fail to diagnose that sound ever again.
Yep. It is very obvious when it is a hard drive, like a issue with your hard drive. It'll be very obvious. So back up your data and replace the drive. When a hard drive with the operating system dies, the system will lock up, and if gives the error, it will give the error no boot device present. So if it is a second drive, it will stop showing up in Windows Explorer. In that case, both power and data cables and connectors should be checked. So if it just kind of disappears, make sure your wires are connected properly, because it could just be that it's not receiving power. But if you hear that grinding and squealing, back up your data, replace the drive. It's the only thing you can do. And we got a quiz that some people have already answered somehow. Stop sharing. Lab sim, it'll take you directly to the labs related to this session. And then finally, objectives revisited. We should be able to explain the purpose and methods of hard drive partitioning. We should be able to explain the purpose and methods of hard drive formatting. And then we should be able to identify common hard drive problems and explain how to maintain and troubleshoot these issues.